so tonight's homework is really, really simple, I think. But then it's going to start getting a little more rigorous, even though you actually learned all these concepts before. So I'm going to bring up expolog 1. So you don't even have to start graphing yet. I think all the graphs might come on tomorrow's assignment. And it's going to be really fast now. There's only 4 worksheets for this chapter. So basically there's 3, and then the 4th one is like the practice test. Yeah? But I'm not sure if I'm going to give a test on it yet. I have to see what happens when we take the test on rational first. Okay, so the first problem, you're solving some equations. Okay, let me give you an equation. Let me give you an example. How about something like this? This is the kind of problems you see on the SAT and ACT, except a little bit tougher. How about 2 to the x plus 1 times 8 to the x minus 1 is equal to 4 to the 3x minus 2 times 16, no, 32 to the 2x plus, what number haven't we used yet? 4. There you go. How would you solve for x? Without using your calculator. Of course, if you have a calculator, you guys know how to solve any equation, right? Just make one side 0 and graph it. And wherever it crosses the x-axis, that's your answer. But you're not allowed a calculator. Come on, this is SAT.
Make the base the same.
Exactly. Change and make it all a common base. So what number is a common base for 2, 8, 4, or 32? 2. Well, actually, it could be 4, right? Could be 32 even, but to make it simple, we'll just do 2. So change everything to base 2. 2 to the x plus 1, and then 8 is the same thing as 2 to the 3rd, correct? 4 is 2 squared. No need to take notes on this, right? In fact, you know this thing, you guys are still taking notes. Why don't you do what they did last year? When I finish, take a picture of the board. Okay, never mind, just keep scribbling. 32 to 2. I'm telling you, if you just listen and absorb, you learn it better. But okay, now all you have to do is use your properties of exponents. Okay, what do you do with the exponents when it's outside the parentheses? Multiply. So 3x minus 3, and then multiply. So is that 6x minus 4? And then over here you're going to get 2 to the 10x plus 20. Now what do I do with the exponents in this case? You add. So when you multiply thingies, you add the exponent. So 2 to the 4x minus 2 is equal to 2 to the 16x plus 16. And then now you just use some common sense. If 2 to the gorilla equals 2 to the banana, then shouldn't gorilla equal banana? Okay, and then now it's just an algebra 1 equation, right? Sometimes it might come out to a quadratic or a cubic, and then you're going to have to do synthetic division again. Just believe me, you're going to be doing synthetic division this whole year, the next year. See, there are certain things you just shouldn't forget until you finish your math career. Okay, so solve this. 12x equals negative 18. Oh, this came out pretty good. X equals negative 18 over 12, which can be reduced to? Box that, that's the answer. Easy, yeah? Okay, okay, wait, let me make a problem. Shh. I don't want to do the same problems as there. Don't look. I mean, this is how I can make quiz problems. Shh. Minus 9 minus 1/3. Shall we do that? That would be fine, I guess. So no, you do. A squared minus 28u plus 9. Okay, here. 3 times 3 to the 2x plus 9 is equal to 28 times 3 to the x. And then of course, here, this is how I kick it up a notch. Okay, see, that's what goes on in my mind when I make a quiz, and then now here's the finished product. Solve for x. How would you solve for x in this equation? See, some of you going, what the heck is happening here? Well, how about put it, like, make one side 0, right? So 3 to the 2x plus 1 minus 28 times 3 to the x plus 9 equals 0. Now, did you guys learn u substitution last year? When do you use u substitution? Whenever Mr. Rubash says to. No! Okay, look. Isn't 2x plus 1, isn't that the same thing as 3 times 3 to the 2x? Because that's like 1 and then you add the exponents, right? So when you have 2 to the x, 2x plus 1, then you can just separate the 3 like this. Now, how do you know when to use u substitution? Well, doesn't this have quadratic form? This power is double that power, and that's a constant. This has quadratic form. So last year, did you guys let u equal to 3 to the x power? Does that sound familiar? Yeah, but this year, we're not going to just have a quadratic form. We're going to have cubic form, quartic form, and then you're going to use synthetic division. So if you let u equal 3 to the x power, what do you get here? 3 times u squared minus 28u plus 9 equals 0. See, that's the only reason why you let u equal to something, because then now it just looks like something you guys can handle. And we're going to be doing that with logarithms, when we have trig functions. Okay, so is this factorable, or should I use the quadratic formula? It is factorable. 3u and u. 3 and 3 or 9 and 1? 9 and 1 or 1 and 9? Okay, 1 and 9 minus minus, does that work? Is outside inside negative 28u? Yep, it is. So therefore, u equals 1/3 or 9. Box that, that's the answer. No, that would be like a minus 3 or 4. Now you gotta resubstitute in. U was 3 to the x power. And then now we can do it. 3 to the what power will give you 1/3? Negative 1, right? 3 to the negative 1. And 3 to the what power equals 9? 2. Now you box that, that's your answer. So you're going to have a couple of those on tonight's homework. One of them, look at F. You're going to have to do synthetic division because it's going to come out to a cubic when you make the u substitution. All right. Okay, so you have a variety of equations to solve there. The first 3, you just make a common base and make u substitutions on the other if you have to. Okay, but look at number 2. Do you guys know how to, did you guys do problems where you factor with negative and fractional exponents? Some of you going, yeah. Well, I know your book has them in it. It's just a matter of did your teacher assign them. Oh, and by the way, what if it came out to like 3 to the x equals like 5? 3 to the what power equals 5? That's not something I know, Mr. Parquet, and that's when you got to use logarithms. But we're not going to get to that until either tomorrow or the next day. Okay, now the reason why you guys have to be able to factor with fractional and negative exponents, because when you go to calculus, that's what's going to happen. So how I wrote those 2 problems over there is what I did is I start with a problem. Okay, you don't know what I'm going to do. Okay, I'm going to make it a little different. So I have a 4x plus 5 there. So what am I make that 3x plus 1? And then let's just go 2/3 power then. Okay, so you're gonna have no. Should I do 1/3 power? Yeah, let's do 1/3 power. Okay, so here's a function. Next year you're gonna learn this thing called the derivative. You don't know what I'm doing. You don't need to know. Okay. So this is what's gonna happen. X plus 1 to the 1/3. You know what? I'm gonna change this 3 to a 4. I think it makes the problem better. Okay, plus x squared times 1/3, 4x plus 1 to the negative 2/3 times 4. Okay, so you don't know what I did, but you don't need to know. Okay, here's the problem. Factor it. Because next year in calculus, you have to know when a function is positive or negative. So what you need to do is you need to make a number line for the function. There's gonna come a point in calculus next year where all you're doing is you're making number lines. So you have to be good at that. So remember how to make number lines? We just did it last chapter, right? Binapsony. So what do you need to do? You need to factor this. Before you can even make a number line, it has to be factored. So how do I factor? Now look at these two things. What can be factored out? Well, I see a 2 and I see a 4.
2.
Okay, well, that took a while. I see an x and I see an x squared. So we factor out an x. I see a 4x plus 1 to the 1/3 and a 4x plus 1 to the negative 2/3. So that means I can factor out a 4x plus 1 to the... See, we've got fractions and negative numbers. All hell is breaking loose. Okay, let's go back to algebra 1. I'll erase this side of the board. Okay, let's say you had 6x cubed plus 8x squared. What can you factor out? Look at the 6 and the 8. What can be factored out? 2, and then look at the x cubed and the x squared. X squared, what's going to be left? 3x plus 4. Okay, now, how come you can do that with whole numbers, but once you throw fractions and negative numbers in there, all hell breaks loose? It's the same thing. How did I know to factor out x squared and not x cubed? Because 2 is smaller than 3. You factor out the smaller one, right? Okay, now let's go back to here. So, 4x plus 1 to the 1/3, 4x plus 1 to the negative 2/3. Which one is smaller? Negative 2/3. Do I have to explain why negative 2/3 is smaller? I had to last year, that's why. You sure? Okay, I won't draw the number like that. And then, what about when you have a fraction? Whenever you see fractions, you need to factor out the least common denominator. So there's no fraction here, so it's like over 1. This is over 3. So what is the least common denominator for 1 and 3? 3. So you should also factor out a 1/3. Whenever you have fractions, you need to factor out the least common denominator. Okay, let me show you an example, because some of you are going to say, what, girlfriend? What if you had 3/4 x plus 2/3? How do you factor that? What is the least common denominator for 4 and 3? 12. So you factor out a 1/12. Why do you do that, Mr. Park? Okay, well, tell me what's inside the parentheses. 9x plus 8. That's why you do it. Then you only have whole numbers in here. So now you know, on the number line, negative 8/9 would go on the number line, right? Okay, so does everybody agree this is what can be factored out? Okay, that's the easy part. What's left? If I factor out this from that, what's going to be left? 3. 4x plus 1 to the, what power do I need to put right here?
The first.
So everybody got it. It's 1 then. Yes, it is 1. To the first. But we don't write to the first power, right?
No.
No, we just leave it. If it's not, nothing's there, it's 1. Does everybody understand why it's 1? I don't think so, because every year students struggle with this. Even by the time we get to the test, I give you 1 and then don't have even numbers. There's no numbers there. You got to know what to do. Well, how do you know this is the factorization of that? Well, factoring is just the reverse of the distributive property. If I distribute the 1/12, do I get this? Yeah. So same thing here. If I distribute this thing, you should get the original problem. So when I multiply this times this, the 3's cancel out, and then you get 2x, which is there. And then when you multiply these two, I'll put the 1 there for your viewing pleasure. Don't you add the exponents when you multiply? Negative 2/3 plus 1 is 1/3. So that's why it works. Factoring is the reverse of the distributive property. Okay, let's move on to the next one. If I factor this out from that, what's going to be left? Look at the number first.
2x. Wait, no.
Okay, 2x and, or is that it?
Yeah.
And again, if you don't know, if I go this times this, do you get that?
Yeah.
Yes, that's how you tell. So that's correct. So that's the answer right there. No, you gotta simplify. You can simplify what's in the brackets here. So what happens when you distributize the 3? 12x plus 3 plus 2x. Okay, now we can write the final answer. Your final answer is 2x over 3 times 4x plus 1 to the negative 2/3 times 14x plus 3. There you go. That's how you factor it. So when you make a number line, you're going to have 0, negative 1/4, and negative 3/14 on the number line. So again, in order to make a number line, everything has to be factored. That's why you got to be able to factor with fractional and negative exponents. Okay, so you got 2 problems right there to practice on. And then the word problems. Now these word problems are just like the ones on the PSAT and the SAT. You have to be able to read a problem and then write an exponential function from it. So you guys just took the PSAT, so you guys should be good at this, I would think. Okay, here. Carbon dating. Do you guys do carbon dating in chemistry? Who took chemistry last year? So you guys never did carbon dating? You guys even know what carbon dating is? What about dating? Oh my goodness. Okay, really? You guys never learned about okay, suppose you're having a barbecue in your backyard. And then your dog starts digging. And then your dog brings up a bone. You're like, whoa, this bone looks kind of funky. So is this bone from a barbecue from last weekend? Or is it from an ancient civilization years ago? How can you tell? Yeah, you take it to the laboratory and they can carbon date it. Because carbon decays at a certain rate. Really? You guys never learned this in chemistry? What about honors chemistry? Who took honors chemistry? Who teaches that, Boric or Tomiyasu? Both. So really, if I go to them and ask them, did you guys teach carbon dating? They're going to say no. I think they did. Okay, anyway. Okay, I had a D in chemistry when I took it, but I remember something. Like, I think, what is the original number of carbon, for carbon? 16? 12? 12? So when you go carbon 14, then what is that? That's an isotope, yeah?
Yeah.
Does that mean 2 more or 2 less
2 more
protons or whatever?
2 more.
2 more neutrons.
Yeah.
So it makes it radioactive then.
Yeah.
Maybe that's not the correct word. What do you call it when it starts decaying?
Unstable.
Unstable. Okay, that's the word. Anyway, the half-life. Why am I teaching you chemistry? I had a D in chemistry. But then I also had a D in math too. So the half-life of carbon 14, I believe, is about 50 years. Tanaka, is that about right?
I don't know.
I had a D. You guys had A's, I bet. I think it's about this. You can Google it if you want. Okay, so just from this, can I write an exponential function for this? This is like saying the price of a car depreciates 50% every year, right? So y equals y naught. What is this y naught business? That's your initial amount. Whenever you have an exponential function, this number in the front is your initial amount. How much you have at the very beginning. Okay, now since we're talking about half-life, we put a half in the parentheses. But it takes 50 years for a given amount to decay to half of that. So what do I put up here?
C.
t over 5750. Come on, this is a PSAT. Does this even look familiar to you guys? Did you guys take the PSAT? Oh yeah, was it last week or a couple weeks ago? Because look, what happens when you, okay, here, let me show you how it works instead of some of you just memorizing things and you just purge them. What happens when you plug in t equals 0?
Get 0.
What is 1/2 to the 0 power?
1.
1, and then what is y naught times 1?
Why not?
You get y naught. You get y equal y naught. See, this is how much you have at the very beginning when t is 0. We call that your initial amount. Okay, what happens when you plug in 5750 for t? What is 5750 over 5750? 1. What is 1/2 to the 1?
1.
So what do you get? You get y equal 1/2 y naught. See, so it takes 5750 years for the whatever amount you started with to decay to half of it. That's how you get these numbers. But I think on the PSAT, what, you guys just memorized things on the cheat sheet? There's a cheat sheet. Did you guys look at the SAT website with the cheat sheet? I spent half my career making that paper, you know. Yeah, I did it. Okay, so here. So you have to be able to read a phrase, and then you got to be able to write an exponential function for it. Okay, let's do another one. A population of flies increases 30% every 5 hours. Okay, how do you write an exponential function for this? Y equals y naught. Okay, basically, what number do I put in parentheses? 1.3. Basically, like this one here is like 1 minus a half, right? This one is 1 plus, you guys know why it's 1.3 or just memorize? So, if you have something and then you add 30% of it, what do you get? You get 1.3x. See, that's why it's 1.3. Every 5 hours. T over 5. And then if they give you an initial amount, they might say, well, the initial amount of flies is 1,000, then this would be 1,000. Do you guys understand why this number in the front is your initial amount? I explained it. When you plug in 0 for t, that's what you get. Okay, so you have to be able to read these things, and I think you guys can do it. And then the last one, number 6. If I give you some data points, now we already did it with a linear function, we did it with quadratic, we did it with cubic. Did we do any others so far? No. Now in this chapter, you're going to have exponential, logarithmic, and then when you study trig, you're going to have trigonometric function. So what if you're doing a chemistry lab or a physics lab, and you plot all these data points, like that, something like that, and you go, eh. Now, you could write the equation of the best fit straight line, but this doesn't really look like a straight line. You could write the equation of the best fit parabola, that would be okay, or a cubic function. But to me, this kind of looks like an exponential function. So, you guys remember how to write the equation of the best fit straight line? Remember? Oh boy. You go to 2 variable statistics. I forget what they're labeled, so you just input the points. So in tonight's homework, you just input the points. -3, 1. What's the next one? -1, 2. 1, 4. You can pick whichever one you want, but see, that's why you got to be the smart one. You got to look at your data points and go, yeah, I could write a best fit straight line. You know what? Now is the time I should teach you guys something. Okay? So you punch the points in, and then just remember to select exponential, because it says write the equation of the best fit exponential function. And then remember what I told you to do? Okay, you know what? I'm going to do it on the screen right now. Then, 'cause it doesn't sound like you guys remember. Even though you have to do it 3 times already. This is the 4th time. I'm telling you, every time we come across a new function, I'm going to make you do a best fit curve, you know. Okay, so let's go to our graphing calculator, HP calculator. Whoop. Is that as big as it gets? Whoa, that's too big. Let's expand it a little more. Okay, the calculator doesn't change size. Okay, go to apps, 2 variable statistics. Okay, you see these numbers? Why don't we clear them first? So shift, clear. Clear all, there you go. Okay, punch in the point. What is the first one? -3, enter. -1, enter. 1 and 2. 1, 2, okay? And then now we do the y coordinates. What are the y coordinates? 1, 2, 4, 7. 1, enter. 2, enter. 4, enter. 7, enter. Okay, you input the points, and then you go to, what did I tell you guys to do, remember? Plot first, because remember something happened on, I remember one quiz. You have, because if you're in a certain one and you just plot first. Okay, now go symbolic. See how it says linear? If you change it to exponential, like that, see, there's nothing there. So that's why you need to plot first. So plot it, and then press symbolic. Now you got it. Right there. That's your best fit exponential function there. Now, I wanted to teach you something. Is anybody taking AP statistics? You guys learned about the correlation coefficient? Okay, I wonder if you, okay, so you're used to using this calculator? Okay, where do you get the correlation coefficient then? What do I have to do?
On the calculator?
Yeah.
Oh, I don't know.
Wait, you guys gonna be taking an AP exam on this, right?
Yeah.
Yeah, you guys gotta know where it is then.
Oh, we just use Stafford.
What?
We just use Stafford.
Say that again.
We use like a website.
Oh, you use a website. You guys don't use the calculator?
Not usually.
What? Why did we buy this calculator then? Okay, wait. I'll try to figure this out. Who else is taking AP stats?
And you
Co-
go to
what?
the data table.
Go to number.
Go to number.
Yeah.
Number, right here.
Yeah. And stat.
Stat. Oh! Okay, there we go. So the correlation coefficient is 0.99567. Is that good or bad? Those of you taking AP stats. That's very good. The closer to 1 it is, then the more it fits the curve. So yeah, so you can pick any curve you want. Here, let me show you. Like for example, if you pick a linear function, let's try that. So we go to symbolic. Hey, how come it's not letting me go?
Press OK.
Okay. Symbolic. Okay, now let's go to linear. Select linear, and then plot first, and then symbolic. Okay, now so you said press number, statistics, and there you go. See how the R value is now 0.9375? It's getting farther away from 1. So the farther away from 1 you get, then it's not as good a fit. So your goal is to get it to be 1, but in order to be exactly 1, that means they actually have to lie, all the points have to lie on the same straight line, which when you do an experiment is almost impossible, right? So so your goal is you want that R value to be as close to 1 as possible. So if it's 0.9, like 0.98 like we had for the exponential, then that's good. Let's try a quadratic just for funsies. Press OK. Symbolic, let's do a quadratic instead. Boom! Plot, and then symbolic. Okay, so what did I forget? Number, statistics. What the heck is that? It says not a number? No, there is no R value for the quadratic. Why would that be? You guys know that NaN means not a number, yeah? You guys ever seen that before when you use this calculator? We have a calculator. Okay, anyway, you want that R value to be as close as 1 as possible. So we call that the correlation coefficient. Anyway, this is just extra stuff I'm telling you now, but now since I told you, I can put it on the quiz. Okay, I won't then. All right. Okay, so that's what you have. Well, I actually did it for you right there. So when you're doing, you know, like chemistry or physics labs, what else would you, biology labs? That's the kind of thing you gotta look at. But I think in most science classes, don't they just make you write the best fit straight line, pretty much? Wait, did you guys have to have done that in chemistry, right? Best fit straight line. Because Miss Tomiyasu was telling me about an experiment she gave you. She said something about you had to do you get some points and you make a best fit straight line, and then you can extrapolate over here to figure out absolute zero or something. You guys did this experiment? But see, when you guys do it in chemistry, I think she told me, you just eyeball it, right? What you think the best fit straight line is, right? But then why, when you have this technology, right? Just punch in the points and boom, it'll tell you exactly what the best fit straight line is. You don't have to eyeball it. In fact, if you're a scientist, you think you can just eyeball stuff all day long? I don't think so. What do you mean, yes? Okay, we're done. Today we finish early. Okay, tomorrow though, then we're gonna, and again, so we're gonna learn some base graphs tomorrow, the e to the x. By the way, you know what? Since we have time, I'm gonna teach you about the number e right now. Because it doesn't seem like, did you guys learn about the number e? Yeah, I know you guys did, but how did you guys learn it? I don't know. Huh? Wait a minute. Now then, that's like saying, okay, what do you guys like to eat for breakfast? Oh, blue. What? Okay. Since we have time today, I'm just going to talk about why is this number e so important? Why is it in every textbook? In fact, in calculus, you're going to get to a certain point where almost every single answer has e or natural log in it now. So you're going to have to know what this number e is. So can somebody tell me what it is? Somebody can impress me. Tanaka.
Isn't it like the area under a certain graph?
Oh, you had Mr. Rubash then, yeah? Well, yeah, it can be. Okay, here. So this is what I think Tanaka is saying. Do you remember what the graph is? Who had Mr. Rubash? Y equal 1 over x? Who had Mr. Rubash? And remember, you're on video now. From 1, okay, so if you measure this area, when this area comes out to exactly 1 square unit, then this x coordinate will be the number e. I think that's the way Mr. Rubash teaches it, yeah? Okay, so that's one way of getting e. In fact, well, since we're on this subject, I'll tell you another way of getting e, which is in the notes, but I don't know if you guys even look at my notes. Oh, I remember what I did last year. I put a problem from the notes, and only about 3 people got it. And then after that, then people started reading the notes. So another way to compute e is to do this. 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial. And you keep on adding these numbers forever. And if you can add up these numbers forever, you will get exactly e. Here, let me show you. What is 0 factorial again? 1, so that's 1. What is 1 factorial? 1. What is 2 factorial? What is 3 factorial? Come on, we just did bin absentee, so you know factorials, right? What is 4 factorial? 5 factorial. 6 factorial. 7 factorial. 8 factorial. 9 factorial. Anybody? Okay, here's the easy one. What is 10 factorial then? If this is 9 factorial, what would 10 factorial be?
3, 2, 8.
You multiply it by 10, tack on another 0. Okay, 3,200,000. Wait, something's wrong here. Is my memory failing me? I used to memorize all the factorials of 3,328,000. 1,000,000. 1,000,000. No. Yeah! No, I'm serious. Once I hit 55, and I'm way older than 55 now, the memory is just, oh man, here's time and my memory. So here's 55 years old. It just started to decline, and it's just a slow burn now. That's what it is. 3 million. Say no, 3 million. 3,628,800. I think that's what it is. Therefore, this is 362880. Anyway, if you keep on adding these numbers up forever, you get exactly E. Does that sound familiar enough?
Yeah.
Because look, 1 plus 1 is
2.
2. 2 plus a half is 2.5. And then add to that 1/6. What is 1/6? 0.16 repeating, right? What do you get? 2.6666. And then now add to that 1/24. And you can see that these numbers are getting closer and closer to something. Okay, did at least your teacher tell you the 15 decimal places of E then? Because I know Mr. Cropsey does. Who had Mr. Cropsey? Okay, 15 decimal places of E? Oh my gosh. Please help me. Please. Please. Okay, here. So, I guess I'm going to be the one to teach it to you. So here, E is approximately 2.7. 18281828459045. These are 15 decimal places of E. And you can ask anybody who took this course before, you're going to have to know it. You know why? Because on one problem on the test, it's going to say round your answer to 15 decimal places. Yeah. You can ask anybody who took PCH before. How am I going to memorize this, Mr. Park? Well, you have to know some history. Are you, Mr. Cropsey, history? Oh boy. That's okay, I'll teach you. Okay, so you have to know the 2. If you don't know E is 2 point something, you just go home, cook rice, okay? Now you just know some American history. Who is the 7th president of the United States? Okay, who's taking history now? When did students take history now? 11th to 10th grade? When did you take U.S. history? It used to be 11th grade. Okay, and then did you take AP?
No.
Okay, it doesn't matter, come on. I had a D in history, I can remember the 7th. What we got, Washington, Adams. Oh. Monroe, Madison?
That's like cow.
Madison, Monroe? 5th president? Jefferson. Okay, Washington, Adams, Jefferson. Monroe, Madison, Quincy Adams, Andrew Jackson. Andrew Jackson is the 7th president of the United States. He served 2 consecutive terms beginning 1828. See, 1828, 2 consecutive terms. His favorite triangle, the 45, 90, 45 triangle, boom, that's how you memorize 15 decimal places of E. Or you can think of your own story. What about pi? Do you guys know how to memorize pi to 15 decimal places? Do I have to teach you everything? Okay, how many decimal places of pi do you know? And don't say 2. 3.141592653589793. You know how I remember that? You make a story about it, just like this one. Andrew Jackson, 7th president of the United States. 2 consecutive terms, beginning in 1828, favorite triangle, 45, 90, 45. So for pi, you just make a story that's like personal to you. So first, you gotta know the first digit is 3. If you don't, just go home, cook rice, right? Okay, now I gotta think. How old am I? I'm 61 now. So, 47 years ago, I was 14 years old. The following year, I was 15. That year, my grandmother was 92 and my uncle was 65. 30 years before that, he was 35. 54 years later, he was 89. 10 years before that, he was 79. And that 3 is the same as that 3. That's how I remember it. But you gotta make the story personal to yourself. Okay. Okay, I'm just telling you, you're gonna have to know 15 decimals apply, places apply on the test. Okay, now, these are 2 ways to figure out E, but the way that I think your Algebra 2 teacher taught it to you was this. The limit as n approaches infinity of 1 plus 1 over n to the nth power is E. Okay, now that we have experience with rational function, what does this mean? Limit as n approaches infinity. If you plug in bigger and bigger numbers for n into this thing, like 100, 1,000, 1,000,000, 1,000,000,000, a trillion, a quadrillion, then these numbers are going to get closer and closer to a number like this. And we call that number E because we name it after the mathematician
E.
Don't make me open the door. Euler! It's named in honor of Euler. What other mathematician do you know that starts with an E?
Anderson.
Okay, well, Thomas Edison, I don't think he would be considered a mathematician. Oh, I thought of it. What about Euclid?
Einstein.
Einstein was more a physicist. In fact, he wasn't really good at math. He even admits that. Okay, anyway, so how much time do I have? We got on to 12, yeah? Okay, we got 9 minutes. Okay, I'm going to show you on the calculator. Now, do you know that you can make tables on the calculator? Yes, we did this in Lin Quad. You guys probably forgot already. Purged. It is purged. Okay, so let me see. Apps. Guess I gotta press OK. Apps. Table. Is there a table? Table. Oh, I know. You just go function. That's because here, num. Num is a table, isn't it? Okay, let's clear that thing. See, there. Remember the problem from the last the function quiz? Remember? Find the minimum cost of the can. See how I keep it on my calculator so then I have to do another problem? Just change the numbers. Whatever. Shift, clear. Okay. So I'm going to punch in that formula right there. 1 plus 1 over n to the n. Okay, so parentheses. 1 plus 1 over x. We can't plug in n, so we have to plug in x. Raised to the x power. Raised to the x power. Right arrow. Enter. Now, how do you tell your calculator, plug in bigger and bigger numbers for x, and then show me the result? Well, you go to num. There's the table. Okay, but it looks like the table is starting from... Oh gosh, how come it's so high, the table? There. There. Table is starting at 0. Notice that if you plug in 0, 1 over 0 is undefined. That's why it says NaN, not a number. Anyway, if you plug in 100, you get this. If you plug in 200, you get that. And then you can just... I want it to scroll down. Okay. See, you're not getting the effect now. Here. Scroll down. Hey, Mr. Park, these numbers are getting closer and closer to something. Look, 2.718. The bigger and bigger the number you plug in, look, it's getting closer to this number. What is this number, monsieur? This number is E. And that's how you get E. That's because you know that expression 1 plus 1 over n to the n? That comes up a lot in mathematics. Come on, somebody impress me from Algebra 2. Where have you seen a formula that has something that looks like this? Come on. You're gonna have to know this for tomorrow's homework. Yes or no, did you do this formula last year in Algebra 2? Yeah, what did we use this formula for?
Profit.
Compounding interest, that's right, compounding interest. Yeah, you're gonna have to know this formula, okay? Anyway, hey, this thing over here kind of looks like that, that's right. So anytime you have something that looks like that, you know the answer is gonna have to have something to do with E. And E is a super special number. You guys have no idea how special it is until you actually get to calculus. All right. So, never mind, I'll just tell you tomorrow. Okay, we are done. You guys have 3 minutes remaining. I guess we can just back up already.